Hi, hello, welcome to my class. And today we are discussing about unsupervised. See, you can see that title. Hope you people are learn that supervised classification properly, and you can ask your doubts. Fine, you can ask your doubts, and you can clear your doubts. That is connected with that image classification, supervised classification. In last week, we people discussed lots about image classification, then supervised classification, then different related concepts, right? How the classification methods connected, how we people are resolving error, how we are representing different datas, right? That certain how we people are that representing that training data sets. Likewise, we people discussed different things that clearly connected with remote sensing, then digital image processing. Now we are going through what image classification techniques, right? uh, we people are classifying multispectral images. We people are using multispectral image. That means different that composite image having different spectrum, right? We people are using that multispectral image with different representing different spectra, and we discussed a lot of things. Um, Clearly, how the spectral signature work, what you mean by training data set, what are the errors in training data set. Likewise, different things. That part of digital image processing. Now, on this week, this is the first video on this week. And today, in this week, we people will discuss about unsupervised classification, hybrid classification, post classification smoothing, likewise, fuzzy classification, likewise. Right. So it is all about that dealing with certain raster products, raster images. Hope you people are well aware about what you mean by vector and what you mean by raster. So we people are deals with certain raster product, that is satellite images. That may be panchromatic, that may be that what is that, true color or natural color, or that may be FCC, false color composite, etc. So that see, I already said we people are now running a theory class that's clearly connected with practical sessions. We people are discussing lots of theory, supervised classification, that different classifier, etc. Here also unsupervised classification, we are discussing theory without any practical knowledge. So there are certain limitations. Try to understand the concept. Try to use different different sources, not just my video, different books, different videos, etc., to learn something more. Fine. It is what bit difficult subject. Anyway, we people almost reached the conclusion of this syllabus, and now we are going through unsupervised classification, and next week we will start to discuss about the applications of remote sensing data, etc. Right. Okay, so welcome to my class. Hope you people are understanding my previous lessons. Few people are asking questions. Few people are clearly attending their assessment regularly. Some people are not attending the assessment regularly. Some people are not at all attending the assessment. We people are noticing all those things. Fine. We people are noticing all those things. Try to clear the assessment. Use available resources properly. That is the only advice I can give you. Right. And why we people are using certain classification, that may be supervised or unsupervised. because we want to learn about spatial process, spatial pattern, and spatial behavior. Right? We people are studying about certain spatial what spatial pattern. So that may be including land use, land cover, right? Maybe land temperature, maybe about watershed, maybe about river, etc. So let us start our session. So what do you mean by unsupervised classification and supervised classification? See, the major difference, here, what do you mean by that? If you are comparing with supervised classification, here we are just giving that image to the that machine. We are just taking that image in that machine, in that hard drive, opening with the help of software, just clicking the image classification window. We are just dragging that image to that classification window, clicking for that unsupervised classification. It will show the result. It will show the certain land use, land cover, with the help of we can just define the number of classes based on that. Just that defining number of classes, you can divide for 3 or 2. 2 is not okay. 4, 3, 4, 5, 6. Likewise, just defining number of classes and extracting the result. But in that supervised classification, we are taking training data set from the image, and based on our training, based on our classes and training data set, the machine is providing result. Here the difference is clear. We are not taking any training data set. We are just inserting the image to the machine. Machine means computer, and with the help of certain software, maybe ArcGIS, maybe ERDAS, or this kinds of that image processing software, we are extracting the result. We are mining the data. We are mining the result. That is the major difference. Big difference. Okay, let us go through the lessons. Fine. So unsupervised classification, the process of automatically segmenting an image into spectral classes based on natural groupings found in the data. See, I already said it is an automatic work, mission automated work. Not we people are not collecting any kinds of data and all those things. We people are not collecting any training data set. Procedure: classify the image, identify clustering, accuracy assessment. That is the 3 steps. That procedure: classify the image, means that all done by the what machine. Classify the image, identify clustering, accuracy assessments. Then clustering, that we discussed that the supervised classification having certain algorithms, not type of classes. See, I have seen that your response that different types of supervised classes. No, not like that. There are certain algorithms. Here sequential clustering is there. K means clustering. Then isodata clustering. See, this isodata clustering, that I have experience. I have used this isodata clustering. Right. This both sequential and k-means clustering, I have never used that 2 method. So supervised classification, clustering, a little input from user required, a few assumptions, but means results hard to interpret, may not represent classes we recognize. Cluster pixels in future space based on some measures of their proximity. See, I already said it is a principle that is clearly connected with statistics, mathematics, physics, and all those things. So that is a written definition. You have to go through it. That unsupervised classification, clustering, interpretation of results assigned classes can be useful. Example, in picking up variations within what would otherwise be distinguished as a single class. Example, stressed, unstressed crop in a single field. Clusters can be little instinct value in themselves. Example, sunlit trees, shaded trees is perhaps not a useful discrimination if one simply wants to classify trees, and so clusters may have to be combined. See that it is mentioning about certain disadvantages that is connected with unsupervised classification. So classification K means a large number of clustering algorithms exist. K means input number of clusters desired. Algorithms are typically initiated with attribute at arbitrarily located seeds for cluster means. Each pixel then assigned to closer means. Revised means vectors are then computed for each cluster. Repeat until some convergence is met. Convergent site criterion is met. Example, cluster means don't move between that criterion iterations. Computationally expensive because it is iterative. Right? It's all are the what that how that K means that that type of algorithm is working. Unsupervised classification ISO data iterative self-organizing data analysis algorithm. So that are two algorithms, that is K means, and second one is unsupervised classification as ISO data clustering or iterative self-organizing data analysis, that is ISO data clustering. Same as K means, but now we can vary number of clusters by splitting or merging. Start with user defined number randomly located clusters. Assign each pixel to nearest cluster, mean spectral distance. Recalculate cluster means and standard deviations. Each distance between two clusters, some threshold, merge them. If standard deviation in any one dimension, some threshold, split into two clusters. Delete clusters with small number of pixels. Reassign pixels. Recalculate cluster statistics, etc. until changes of clusters some fixed threshold. See, I already said it is all clear, connected with statistics and mathematics. See, actually, if we are doing with the help of that machine, we are not doing nothing. We are just doing the what analysis with the help of machine. We are not doing any kinds of calculation and all. We just inserting the image and open with the help of a particular image analysis software, and just clicking. We are just giving that click to classify the image, and we are getting information. What is behind that processing? That is that the things these written statements explains certain statistical and mathematical functions. Right? I know that my explanation that is connected when the statistics and mathematics is not enough. I can understand. You get some resources and refer more. Right? That is the only advice I can give you. Okay. Okay, let us continue. ISO data example. See, I already said it is something statistics or see, I already said no, statistics or mathematics. This is the method it is working. Right? Example, unsupervised classification, pictorial representation. It is a land use land cover map, different class 1, class 2. We can change according to our choice. This name we can change. Right? So supervised versus unsupervised. So first of all, unsupervised, unknown classes, no classification error. Natural classes may not match desired classes. Classes based on spectral properties. What is the difference between unsupervised and supervised? Unsupervised. Classes based on spectral properties. Derived clusters may be unidentifiable. A post stereo cluster identification is time consuming and tedious. Unexpected categories may be revealed. Then what do you mean supervised classification? That we already learned. Predefined classes, that means based on our training data set. Serious classification errors detectable. Defined classes may not match natural classes. Classes based on information categories. Selected training data may be inadequate. A priori class training is time consuming and tedious. Only predefined classes will be found. See, based on our assigning that training data set, that mission will classify according to our training data set. That is the major difference between supervised and unsupervised classification. So, my dear students, it is the simple video. We are near to finish our syllabus. So, watch the videos, my videos, other videos, get some resource, some books, read it, ask your doubts. For a simple video, I can't explain more than this. Fine. It will see it is that class. If you are extending the time limit, it is quite a bit difficult to download. See, you know that the range problem and all those things. I'm living in a hilly area, and it is very even in that people in living in town area is bit difficult to download and upload these kinds of things. So that's why I'm just limiting my explanation. Hope you people are understanding my classes. At least little things, fine. And you can ask your doubts, fine. You can ask your doubt with the help of GIS and remote sensing. We people are communicating certain things, fine. We are extracting with the help of the different methods. We are extracting what is needful information, mining data from the images. So with the help of that GIS and remote sensing, we people are communicating. So thanks for watching my video. Kindly attend the classes. Kindly attend the what is that assessment. So thank you, thanks a lot.